Hello and welcome back to Just Code It. Today we're going to take a bit of a detour and review a problem that I encountered in the real world and got to use a LLM and a little bit of coding to solve it using LangChain, LLMs, and Llama. The issue was I had a long list of over 1,000 expenses and I wanted to see if they were deductible or not. The example expenses that we're going to use are this, and what the LLM is going to decide on is using the product name. Basically, everything else is just information about the expense, but what it's going to use to classify it is the product name, and then it generates the product category, is deductible, and then justification. I actually used this to do my taxes this year, and it worked pretty well. So let's just get going. Up top, we just have some configuration, so file paths, default values. What I found is the Llama 3.2 is actually pretty good for only being a 3 billion or 2 billion parameter model. And another one that I ended up using for the full pass was the Phi-4. It did really well for some reason. Some of them, even if they were bigger, like the Gemma 327 bill, actually performed all right, but did not perform as well as it showed for 27 billion. So I ended up just going with the Phi-4 for the final run. After that, we're going to get into the code. And with our first method, we're going to load in that prompt template. I first started with this Markdown prompt because I just like writing in Markdown, but quickly I realized I was limited there. So then I actually went to the LangChain prompt template where they have a structure that you can use. I have some other videos on this that I would recommend going back to. Here you can define the type. It's a prompt, inputs, and then the template. And I essentially just copied all the stuff from here into there. What was an issue with this one is I wanted to do some few shot learning, and I think that's what it's called, few shot, yeah, or few shot examples. Here there's actually a example that it will structure it for you, and you can do few shot examples, input, pass it the input. This will be exactly what we pass it. And then the output, we want it to output this JSON. And I give it a few examples. The more examples you can give, the better. Another way you can improve it is tell it a little bit about your company and what areas you're in. Coming back to the actual code, now you understand what this is doing. It's loading up that prompt and throwing some errors if stuff's messed up, setting up the directory, parsing the date time. That's the date time in the code right here. The next two methods we have are reading in the expense data and saving expense data, just data handling. They're probably self-explanatory. Pandas read data frame, pandas write. This next section though is when we start getting into the meat of the code. We're going to initialize our LLM. We're going to use chat Llama. We're going to pass it our configs. Then using a decently low temperature I found is good. I was altering between 0.1 and 0.2. I'm also setting a seed just for repeatability right now. Next method is one that we actually create that LangChain chain, chaining together the prompt, the LLM, and then the JSON output parser, and just saving it to chain and returning it. Prompt goes into the LLM. The LLM's output goes into the JSON output parser. We have not run this though yet. We're just passing back the chain. The next method is one that we use to process a single file. I split this up. I never ended up doing it, but I split it up so that it would be easy to use either async or threading to improve the performance. But with Llama, it's hard to do the threading. You have to set some environment variables, and I didn't feel like doing it. So I just did a single threaded performance. The first part of this method is we're going to extract the relevant data that we want to pass into the prompt. We have product name, unit price, quantity, and order date. Some basic data checks here. And finally, down here, we have it being invoked. We're taking the LangChain and invoking it and passing it an object, which is all of those input variables. I should probably go to the bottom and explain the main function. The main function is just iterating through each one of these steps. You just start with the setups, creating that prompt, creating the LLM, creating the chain, and then this is the process expenses, which then we have process expenses, which is the plural of process single expense. After creating that raw back up at the raw results, we can see that we are invoking, passing it. This is going to be the response from the LLM, and it comes back in a JSON, as you remember. Now we're going to use that direct JSON loads, so our custom JSON parser. And if that parser actually succeeds and doesn't throw an error, we then go on to extracting the category is deductible and justification, printing it, and returning those. And these will be returned to process expenses, where we're going to essentially just iterate over that. The last method we have is that process expenses. Here, we're going to just start by loading in that data frame, just assign it to df, create some lists for categories, deductibility, that's definitely not a word, and justification. After creating those empty lists, we're going to iterate over the data frame, iter rows, and I believe this returns a tuple, which we're unpacking here. So we get row and index. Inside this for loop, we are doing a try except just to catch any errors and not have it kick completely out of the code. And from there, we're going to call that process single file, pass it the row that we're processing, the full row, with which is I believe a full row of a pandas data frame is a series. So we're passing it a series, the process chain, and the index with the length of the data frame, which I don't believe I use anymore. Let me just check. Yeah, so we don't actually use that anymore. That's a little bit of a scrap from when I was coding this up. If it errors, we're going to just show the error. Moving on, we're just pending all the information we get to these lists. And finally, after we get done with this for loop, we're going to assign those lists to a column in that data frame. We're going to do category is deductible and justification columns, and it should line up with the rows in the data frame already. To wrap it all up, we're then going to save the expense data. Now that we're done with coding everything, let's just check to make sure everything's working and I didn't screw something up. Cool, yeah, it's all working. So it's loading everything, and now you can see it start to process. It's saying 5-star resort is false, and then justification. Let's look at some of these other ones. Microsoft Office, correct. Subscription box, nope. It did not let us get by with that one. One of the ones that it was having trouble with while I was coding was expenses. The smaller model messed it up. Expenses like this, though, technically these should probably not be expense because it's a designer shoe, but we'll let it pass on that. Now, if we want to try out the more advanced models, which do pretty significantly better than these ones, the 5.4, so let's run it again. It's going to take a second to load it into memory, and it will run slower as well, but it gives way better justifications for this one, and it still structures it well. Typically, if you have such a long response from it, it will start screwing up the structure of that JSON that it needs to respond. But the 5.4 is really good at giving you good responses that are long, but not screwing up the structure. After you run this, though, if you have a ton of expenses, I would definitely maybe do multi-threading, multi-processing, or async if you're using an API. I had the luxury of just running this and walking away for 2 hours while it ran, and it ran decently fast. So we did 15 expenses in a minute, but the second run should probably be a bit faster. If you have any questions, please comment down below. I know this is pretty last minute to be doing your taxes, so hopefully this can help, and I'll respond if anybody needs any help. I'll also leave my GitHub link down there so you can just grab the code if you need it. That is it, though. I hope you enjoyed today's video, and I'll see you next time.